So this problem wants us to find out the maximum product subarray. What is a maximum product subarray? It is such a subarray that subarray has to be contiguous. So it is such a contiguous subarray that the product is maximum. That's about it. So the entire problem actually revolves around two ideas, two observations actually. So one observation is that if you multiply anything with 0, like you multiply 0 with any number, the result is always 0. And if you multiply two positive numbers or any number of positive numbers, positive integers, so the result of AB is always going to be greater than equal to A, or AB is always going to be greater than equal to B. So the observation is that we like positive numbers. So positive are good. Positive numbers are good. So, and another observation is that 0 makes the product 0. So these are two observations. What about negative numbers? The negative numbers are a bit interesting because let's say I am multiplying -2 with the current product. It can be 100. So it actually makes the product actually very little, -200. But the property is that if you multiply even number of negative numbers, the product actually becomes positive again, and so it is good. When we are encountering the array, we actually do not know how many negative numbers are going to be there in advance. We do not know that, and 0 makes things a little bit interesting. So how I think of this problem is that we want to separate the whole array into bunch of areas. We want to think of it like areas, and in each of these areas these are partitioned by zeros. So when we encounter a 0, there is actually no point of taking that 0 and multiplying with the whole product I have accumulated so far. So I am dividing the whole search space in terms of zeros. When I see 0, I want to just reset it, and I want to focus on these smaller subsections. I partitioned it using two pointers, start and end, just like this. So in this partition, I observe how many negative numbers are there. Let's say there are 3 negative numbers in these partitions. All right. So if there are 3 negative numbers in any array partition, what we can do? Let's say the partition looks like this: 2, 3, -5, 7, -6, and -5. So what is the maximum product of this partition? How do you think? So 2 times 3 is 6, -5 is -30, -30 times 7 is -210. So -210 times 30, right? So it should be 210 times 30, 6300. So 210 times -6 -5, this is 6300, and it is minus. So the entire product is this -6300. So what is the actually the maximum product? So to calculate this, we have 3 negative numbers, and our goal is to maximize the product. So what we can do is we want to get the closest even negative numbers, even negatives. So we want to get the closest even negative. We want to form this, but our array has to be contiguous. It is a subarray, right? So in order to form a contiguous even negative, how many options we actually have? What is the actual option? It has to be contiguous, right? and we want to maximize the product. So the more the better. So the two options are either we get rid of this portion so that the number of negative numbers becomes even. So if we get rid of this portion, we get 210. The total product becomes 210 if we get rid of the first portion, so that the product becomes positive. And if we get rid of this portion, just minus 5, if I get rid of minus 5, so the total product becomes 1260. So the another answer is 1260. So from this subsection, the maximum product is 1260. How did we form this? It is formed by 2 times 3 times minus 5 times 7 times minus 6. So this portion is the candidate, is the base candidate from this subsection. So we just solve all of those subsections. We solve this subsection, and this subsection. That's all we need to do. We just don't care about zeros, and we just solve all of those subsections. That is actually the result. And one caveat is that these subsections that I just talked about might have just one elements, and those are negative. Let's just say it has only one element, minus 3, it has minus 2 and minus 1. So when encountering 0, we actually, what I do is we actually consider just 0 as a product, because just a single element can be considered as a product. So that's actually the main idea behind solving this problem. The idea is that positive numbers are always good, and if there are even number of negative numbers, they are always good as well. But when there are odd number of negative numbers, we have to make a choice. And when we encounter a 0, we don't bother taking 0 in the calculation. So that's pretty much it.